Good evening, students. So in the previous lecture we discussed regarding what are the theories associated with the slope deflection equation. So now we are going to numericals related to slope deflection method. So here in this problem, analyze the continuous beam shown in figure by slope deflection method and draw bending moment diagram. The continuous beam is given in the problem. We have to analyze this beam. We have to determine the bending moment diagram. That is the ultimate aim of the problem. Now let us see what are the steps involved to solve this problem. The very first step is determination of kinematic indeterminacy. So kinematic indeterminacy means what are the possible displacements at B and C. We are having theta B, theta C. This is fixed. So there is no translation and rotations. And also the next step is we move on to fixed end moments. So in this we are having separate spans AB, BC, CD. We have to determine the fixed end moments. So now we will move on to one by one step. The first step is FEM. Fixed end moments. So first AB. I am assuming the AB span as fixed. Here we are having 50 kilonewton, 2 meter, 2 meters, AB, EI is constant. So this is in the form of point load acting at L by 2, L by 2. Therefore, MFAB, which is nothing but MAB bar. In other words, it's called MAB bar or MFAB, both are same, equals, see here with respect to point A, it will rotate in clockwise direction. What is the counterclockwise part? Like this, anti-clockwise. This is MFAB or MAB bar. Here it is rotating in anti-clockwise direction. So what is the reaction moment? If it is anti-clockwise, then we are treating as clockwise. Here it is clockwise, the resisting moment is anti-clockwise. Here it will become MFB. So this is reverse direction, that's why negative. Because of resisting moment, minus WL by 8 is the equation. Minus WL by 8, W value is 50, minus 50 into L is 4 divided by 8. So what is the value of MAB or MFAB or MAB bar? MFAB. What is the value of MFAB?
Minus 25 kilonewton meter.
Minus 25
kilonewton
meter. Similarly, MFBA equals WL by 8. This is plus WL by 8 because the resisting moment is clockwise. 50 into 4 divided by 8, hence it will become plus 25 kilonewton meter. Now I am taking next span. I am assuming span BC as fixity. (15 kilonewton per meter, 5 meter, BC. So MFBC equals minus WL square by 12. Minus WL square by 12. UDL carrying W intensity fixed. Then here the resisting is anti-clockwise. Here the resisting is clockwise. That's why the anti-clockwise MFBC is minus WL square by 12. Minus 15 into L square, that is 5 square by 12.
minus 31.25.
Minus 31.25 kilonewton meter. Similarly, MFCB. See, this is the counterclockwise direction moment is positive clockwise. Here because this is moving in anti-clockwise. Here this is moving in clockwise. The reverse is anti-clockwise. So it will become WL square by 12 So hence this is 31.25 kilonewton meter. Next, CD span. So now I am assuming CD span as fixed. CD span as fixed. The point load 80. This is eccentric point load is given, not acting exactly at center. Here it's having eccentric distance. It's a 2 meter, it's a 4 meter. Span is A, span is considered as B. So this is 2 meter, span is considered as A, and this is B, 4 meter. So this is CD. Resting moment is anti-clockwise, here clockwise. Therefore, MF CD equal minus WAB square by L square. This is the equation you have to remember. These are all fixed end moments. So minus W is minus 80 into A. A is distance 2. This is A distance and this is B distance. Distance A and distance B. So 80 into 2 into 4 square divided by L square. That is 6 square. 6 square. How much?
Minus 71.11.
Minus 71.11 kilonewton meter. Minus 71.11 kilonewton meter. Next, we are taking MF DC. MF DC equal. See, this is counterclockwise is positive, acting in clockwise. Here it is negative, acting in counterclockwise. This is MF CD. So MF DC will become WB A square by L square. WB A square by L square. W is 80. B is 4 into 2 square divided by 6 square. 6 square. How much?
35.56.
35.56. So this is regarding first step. In first step, we have assumed each span as a fixity. For fixity, we have computed the moments. So I have assumed AB as fixed, BC as fixed, and CD as fixed, and arrived the fixed end moments. Next, step 2. Step 2. After applying fixity, the step 2 is slope deflection equation. Please take a note, when you are using slope deflection equation, always the fixed moment is not having slopes because it will resist all kinds of rotations and translations. Hence here theta is 0. Here also theta is 0. The equation is given by final moment MAB equals MFAB plus 2EI by L into 2 theta A plus theta B plus or minus 3 delta by L. This is the slope deflection equation, but in this problem where delta implies the sinking, it's related to sinking in case of beams. Here I have not given any sinking related data, hence we have to ignore this. This is 0 because there is no sinking of supports. And also when I am talking about AB, 2 theta A will come. Similarly, if you are talking about MBA, it is MFBA plus 2EI by L into 2 theta B plus theta A plus or minus 3 delta by L. This is 0 because there is no sinking in problem. So I am talking about span AB. That's at that time 2 theta A. If I am talking about span BA, AB, BA, this is 2 theta B. This is the only difference. For each span, similarly if you go for MBC, it will become MFBC plus 2EI by L into 2 theta B plus theta C. If you come to MCB, then it will become MFCB plus 2 theta EI by L into 2 theta C plus theta B. Likewise, we have to apply two equations for each span. Here how much span we are having? AB is one span, BC is second span, CD is third span. Totally we are having 3 spans. How many equations? 3 into 2. Totally 6 equations we are getting. Clear? For MAB we are getting one equation, MBA another equation, MBC is third equation, MCB is fourth equation, MCD is fifth equation, and MDC is sixth equation. So for each span we are getting 2 equations. Likewise, I am going to apply all the values. Now I am coming for MAB. MAB equals, what is the value of MFAB? Minus 25 plus 2 EI. Here EI is constant. You can expect this is EI, 1.5 EI, 2 EI. Then for each span, relevant EI we have to apply in the problem. But in this case, I have clearly mentioned EI is constant. When the EI is constant, take EI, same. EI by L. What is L? I am talking about BA. What is the length of BA? What is the total length of BA? 4. 2 EI by 4 into 2 theta A plus theta B. I already told that in a given problem, A is fixed. If A is fixed, then theta A is 0. Why theta A is 0? Because fixed support. Because fixed support. Similarly, you just consider this as okay. You simplify in another way. MAB equal 2 by 4. 2 by 4 is 0.5. 0.5 EI theta B minus 25. Take as equation number 1. Take as equation number 1. Next you take MBA. MFBA is 25 plus 2 EI by 4 into 2 theta B plus theta A, and delta will closes. So what it implies? Theta A is 0. Theta A is 0 because fixed end. So what is the remaining equation? MBA equal 2 to the 4. 4 by 4 1. So it will become EI theta B plus 25. Take equation number 2. Equation number 2. Next I will come to span BC. Here we are getting MBC and MCB. MBC equals MFBC. What is MFBC? Minus 31.25. Minus 31.25 plus 2 EI by L. What is the L value? 5. 2 EI by L into 2 theta B plus theta C. Delta is 0. Here theta B, theta C both will come. Why? Because both are simple support. If in case that is fixed, then that is 0. Here both are intermediate supports. Hence both the rotations will come. Now you just modify the equation. MBC equal 2 to the 4. Take the calculator. 2 to the 4. 4 divided by 5. What is the value?
0.8.
0.8 EI theta B. Similarly, 2 by 5 into theta C. What is the value of 2 by 5?
0.4.
0.4 EI into theta C minus 31.25. Take this as equation number 3. Similarly, next to come for MCB. MBC, MCB. MBC, MCB. So MCB will become MCB bar. What is the value of MCB bar of MFBC? MFBC is over MFCB. 31.25 plus 31.25 plus 2 EI by 5 into 2 theta C plus theta B. See here C first, 2 theta C. Here B first, 2 theta B. Here A first, 2 theta A. Here B first, 2 theta B. That's all. So if you modify this equation, you are getting MCB equal to 2 to the 4. 4 by 5 is
0.8.
0.8. 8 EI
theta C
theta C plus 0.4 EI
theta B
theta B
plus
plus
31.5.
31.25. Say equation number 4. Say equation number 4. Say equation number 4. Next, once AB is over, BC is over. Next, CD. For CD span, once again we are getting two equations. So MCD equals MCD bar. What is the value of MCD bar? Minus 71.11 plus 2EI by L. What is the length? 6 into 2 theta C plus theta D. But here theta D is 0. Why?
End support fixed.
Fixity. Because of fixity. So MCD equals 2 2s are 4. What is the value of 4 by 6?
0.66.
0.66 EI theta C minus 71.11. Say equation number 5. Say equation number 5. Next, MDC. MDC equals MDC bar or MFDC 35.56 plus 2 EI by L. L is 6 into 2 theta D plus theta C. But here theta D is 0 because fixed, and delta is also 0. Why? Because no sinking. There is no sinking in problem. Now MDC equals 2 by 6. What is the value of 2 by 6?
0.33.
0.33 EI theta C plus 35.56. Say equation number 6. For 3 span, we got 6 equations. Once we got slope deflection equation, the next very important step is joint equilibrium condition. Joint equilibrium condition. Generally, joint equilibrium condition, fixed ends are already in equilibrium. There is no joint equilibrium. For intermediate B, we are having two spans. At joint B, BA plus BC. At joint C, CB plus CD. Okay. At joint A and D, 0 because they are already fixed. So joint B will come. For joint B, MBA plus MBC equals 0 for joint B, and also for joint C. For joint C, MCB plus MCD equals 0. There are two joint equilibrium conditions. Clear? Now, what is MBA? What is MBA? EI theta B plus 25. What is MBC? Plus 0.8 EI theta B plus 0.4 EI theta C minus 31.25 equals 0. Now you are getting theta B E1 plus 1.8. It will become 1.8 EI theta B plus 0.4 EI theta C equals, what is the value of 25 minus 31.25?
Minus 6.2.
If you take this side, it will become plus 6.25. Say equation number 7, or you take equation capital A. For this is joint B. Next, I am using this joint equilibrium condition. At joint C, what is joint C? What is joint C? Joint C is MCB plus MCD. What is the value of MCB?
0.8
MCB here 0.8
EI
EI
theta c
theta C plus
0.4
0.4 EI
theta b
plus
31
31.25 plus CD. What is value of CD? Here 0.6 plus 0.66 EI theta C minus 71.11 equals 0. See, joint B, that is MBA means equation 2 plus MBC means equation 3. This is equation 2 plus 3. Here this is MCB. MCB means equation 4 plus CD. Equation 5. 4 plus 5. Clear? First you take theta B. 0.4 EI theta B plus what is 0.8 plus 0.66?
1.46
1.46 EI theta C equals 31.25 minus 71.11.
39.86
30.
9 point minus
If you take shift, it will become positive. 39.86.
86
Say equation B. Now it is the simultaneous equation. Solve equation A and B. You are getting theta B and theta C. Okay. Now that is the fourth step. Determination of kinematic indeterminates. See, this is kinematic indeterminacy. Here 0 0 theta B. Here 0 0. This is theta C. The kinematic indeterminacy is 2. Theta B and theta C. Those are unknowns. We are going to determine those unknowns and substitute the slope deflection equation. You are getting final moments. That's the problem. Clear? What is the value of theta B?
minus 2.73
Minus 2.73 divided by
EI
EI. What is the value of theta C?
plus 27.91
91
divided by EI.
EI. These are kinematics indeterminates. Now substitute these two values in equation 1 to 6 for final moments. For final moments. The last step, fifth step. Final moments. Final moments. Now substitute theta B, theta C in equation 1 to equation 6. Equation 1, you just I'll say an example. Equation 1, MAB, 0.5, EI is same. 0.5 EI into theta B is minus 2.73 by EI. EI will get cancelled. 0.5 into minus 2.73 minus 25. You are getting MAB. Yes, what is the value of MAB?
minus 26.36
0.36 kilonewton meter. What is the value of MBA?
22.27
22.27 kilonewton meter. What is the value of MBC?
minus 22.27
Minus 22.27.
27
What is the value of
MC
MCB?
52.48
52.48 kilonewton meter. What is the value of
CD
MCD?
minus 52.49
Minus 52.48 or 49. What is the value of MDC?
44.85
44.84
85
or 85. So these are the values we just got by substituting theta by theta C in equation 1, 2, 3, 4, 5, 6. That's all. The last thing is BMD. Plotting of BMD. I'll just show you BMD. For this, A, B, C, D. For first span A, next span B, next is C, next is D. First I will draw free bending moment diagrams. For point load carrying this, we are having triangle. The value is WL by 4. What is the value? WL by 4. WL by 4. W is 50. L is 4 by 4. It will become 50. 50, right? Next, for span carrying UDL. WL square by 8. parabolic. WL square by 8. How much? WL square by 8?
46.9.
46.9. Next one is also triangular type, but this is WAB by L because eccentric loading. What's the value of WAB by L?
106.67.
106.67
67.
kilonewton meter. Now I will draw final moments. It's just simple. MAB 26. This is 26.
So minus 1.
It's okay. I will show you. Minus 26. Next, it will become 22. 22. Next, it will become 52. Next, it will become 44.8. I will just join this, 0. This is negative. This is negative. This is positive. This is positive. Negative. Positive. Negative. You just shade these portions. Hatch the portions because of here we require negative steel, positive steel, negative steel. When you are doing design, you come to know what is meant by negative steel and what is meant by positive steel. This is the simple bending moment diagram for continuous beam. Don't bother about these signs when you are drawing this. Just drawing a joint. 22, 26.36, 22, 52, 44.8. Just draw by straight lines. This is regarding BMD. So this is the full 20 marks problem in VTU examination. It's a very important question. Please follow all these things. If you are having any doubt, you just put a message. I will just clarify your doubts. So these are the simple techniques in order to solve problems. The very first step is identifying kinematic indeterminates. Here there are only two kinematic indeterminates. Because this is fixity, there is no translation, there is no rotation. Here, because of this translation is 0, it will become 0. Because of this reaction, this will become 0. The possible is only theta B. Similarly, here only theta C. Here, because of fixity, there is no translation, there is no rotation. The second step is FEM. The third step is slope-deflection equation, arriving equations. The fourth step is joint equilibrium condition. At fixity, there is no joint equilibrium condition, only at intermediate. And if the support, end support is simple support, then only we are getting joint equilibrium condition. The last step is, once we are applying joint equilibrium conditions, you are getting simultaneous equations. You just solve those simultaneous equations, you are getting these kinematic indeterminates. Once you are getting kinematic indeterminates, substitute in your slope deflection equation, you are getting final moments. After that, you have to plot BMD. I hope you are getting the things where you get to solve easily. Thank you for your patience for watching. Thank you.